Hello everyone, welcome to my channel. So, in this video I would like to tell you how to make a smart irrigation system by using an Arduino. If you don't have the Arduino, you may use an online simulators like WOKWI, IoT and Arduino simulators or Autodesk AutoCAD, right? Let's get started with the project, and the first you may have to visit the site. The site is WOKWI, and then this is for the site. So here to see the project, click on here, and there are several of my project that I have done. So let's just click to the smart irrigation system. Here is my project that I just make it today. Before we start the simulations, I would like to explain you all about the code. At the first, we must need the library like for the servo, and then THT is this moisture sensor that I use THT22, and then for the liquid crystal, this is for the LCDs of 16 times 2. And then after we define the library, the next one we define the pin. And then for the TST, I set the pin into a 6 here on the digital, and after that we should define the type of the TST, whether this is TST11 or TST22. And this one I use the THC22, and then for the soil moisture pin I set it on analog 0. For the servo pin I set it on the pin number 9, and the LED pin I set it on number 7, and etc. And then for the liquid crystal, I set it on the number 12, 11, 5, 4, 3, and 2 on this digital pin. At the first, we may create the setup pin. The setup first, we should consider that the LED pins for the output, and then the button pin is put input, but this has a pull up, right? And then the LCD pins is this, and then for the systems we have to initiate the moisture value from the moisture sensor pin, then initiate the edge for the humidity from the THT read humidity, and then for the THT read temperature, and then after that we should consider the what we want to display on the LCDs. First, we print the temperatures, and from the data is from these temperatures from the THT, the unit in Celsius, and then from the humidity we consider from the data is H, from the to read the humidity from this THC22, and then the unit will be in percentage. And then if the digital read button pin is low, it means that the button is not pressed, so it doesn't send any signal to activate the system. And then this one, if the soil moisture value, or you can say the resistance is greater than 500 ohms and the temperature is greater than 25 degrees Celsius, the system will be active, and then the servo will be on. And then If the irrigation is start or is active, the LED will be on, and the digital red LED pin is high, it means on, and then the servo red 1990, it means the servo is just right to open the valve, and then from the LCD it writes the status like irrigation is on. And then if the system inactive, the LED pin is low, it means this indicator is off, and then the servo write to 0, it means from these positions back to these initial positions. And then on the LCD it prints or it says that this irrigation is off. Okay, after that, let I explain you about the hardware. At the first, I have Arduino Uno R3 as the main controllers. For the supply, you may use the lithium batteries, either from the power supply of 9 volts, or you may connect from the power supply from here or from here. And then I have these regulars 16 times 2 LCDs without I to C. So for the wiring, I consider the conventional wirings with the digital pin here. And then as the input for the system, I have this moisture sensor of THT22. The sensor sends the data via the pin of STA to the point 6, number 6. Then this moisture sensor records the temperatures and the humidity of the air surrounding the plant. And then this I have a soil moisture sensor, but due to the limitations of this WOKWI libraries, so I consider these photoresistors to simulate the soil moisture resistance. And the higher resistance from this, it means that the water content of the soil is larger and the soil should be wetter. From the data, it transmits from the A0 to these A0s on the analog pin. And then for the output, I have the servo motor. Servo motors can turn to here 90 degrees when the system is active. It means that this servo is open the valve. And then if the system is inactive, it's back to this initial position, it means the valve is closed. And then I also have this LED as an indicator light. When the system is active, the LED is on, and the system is inactive, the LED is off also. And then I also have this push button to manually water the plant by just click and release this button. Okay, let's start the simulations. At the first, initially it writes the temperatures 39.10 in degrees Celsius, and it says that the irrigation is off. So let I simulate with this moisture sensor. If I decrease the resistance, which means the soil is dry, and see what happens. It will activate this valve to allow the water to into the plant, to the soil. And then what happens if I increase as the water is accumulates by over time? It will stop the irrigations. Then I also simulate with the humidity and the temperature of the air surrounding the plant. If I decrease the humidity and then I increase its temperatures and see what will happen. It does nothing, but it has an influence. It's beyond this. See, I increase the humidity and then I decrease the temperature, it's off. So to allow the servo motor on or off automatically, it's considered by the pod data from the THT or from the soil moisture sensor. And what if I try to run the system manually by using these push buttons and then push and hold for a while? Is it active? And then pause again, is it inactive? And then I will try again. We use to make you more understand about the systems. And decrease it and see what will happen. And decrease and also increase the temperature. It's on. And I try to adjust. Okay, it's off. Okay. And finally, the system is performed the best for the soil moisture sensor and the THT and for the irrigation system. And then in the next video I will simulate it with the real Arduino so you can get the comprehensive understandings what the real system will be. And thanks for watching this video. I hope this video is useful for everyone. Thank you.